Hi, everyone, and thank you for joining today's webinar. I'm Stacy Jambura, the Event Marketing Coordinator here at Live Action and your moderator for today. Today, I'm joined by Joseph Hladek, and he's the Director of Threat Research, Innovation, and Discovery for Live Action, and he's going to be running through our presentation today. Our presentation is titled Detecting Advanced Threats with Event Correlation. During our presentation, if you have any questions, please make sure to enter those into the chat box, and we'll be addressing those at the end of the presentation. So with that, I'm going to hand you over to Joseph, who's going to walk you through how to detect active threats within your network.
Thank you, Stacy. Hello, everyone. My name is Joe Hladek from Live Action. I'm here today to talk about detecting advanced threats with event correlation. I'm the Director of Threat Research, Innovation, and Discovery, otherwise known as Triad. And a little bit about myself. I'm a former red team operator. I used to perform social engineering campaigns, full scope engagements, including infiltration all the way through exfiltration exercises, as well as conducting tabletop scenarios for security planning. But most of my career, I've been an incident responder. I've contributed to investigations, hundreds of investigations, actually, ranging from nation-state espionage, intellectual property and data theft, as well as the more currently common scenarios involving ransomware and financial compromises. I've also led on a number of occasions global operations involving incident response. Oftentimes you have APT actors targeting multiple entities using the same tactics and techniques. And I've led teams to properly track those threat actors and perform incident response for customers that are impacted by those threats. What are the goals for today? Today we're going to talk about what asset risk and threat means, how do we define it, and how does it work with event correlation. And then we're going to talk a little bit about how asset risk and threat prioritizes different teams' workflows. And then we're going to talk a little bit about, I'm going to go through a use case and describe our own strategies around event correlation. Now, there are a number of challenges imposed during incident response investigations, but the ones we're going to talk about today are some of the challenges that our product directly addresses. So one of the major things when an IR begins or the precursors leading up to an IR is determining scope and impact. Impact is a little more complicated. That requires more of the entire investigation to unfold. But scoping is the most important initial exercise to take place. And these three challenges affect that. Let's just say that. So in current times now, you know, we like 10 years ago, everyone's assets were on premises. 10 years forward, now we have hybrid environments, environments where we have assets on premises, we have them in the cloud, in a number of different applications, whether it's user-based web applications or things like streaming services, etc. And then you have mobile devices, the mobile space, where you have phones, tablets, IoT devices. Encrypted traffic also contributes to this, even though it's a necessary protection against threat actors. Eavesdropping or sniffing network traffic, it also imposes a major problem for security operations when they're trying to perform detection or investigation procedures. And as a result of this larger scope and environment with, you know, a mixture of on-prem, cloud, and mobile spaces, security analysts also need to expand their expertise in all of these different spaces. And as a result, hiring analysts that understand and can investigate in these different spaces become more expensive. So we'll begin by defining what risk means. The way we define risk is the potential of an asset or an individual asset to become a threat. So a number of things are involved in making that determination. What is the criticality of the asset? Is this a server? Is it a workstation? Is it a cloud VPC? What are the security vulnerabilities of these assets? Are they, what kind of software and services run on these assets? And then what is the versioning of those software and services? And then how well do each asset adhere to the policies that are configured in the environment? Some examples where we calculate risk are having infrastructure open to the internet that shouldn't be open to the internet, or unauthorized application usage that uses, say, an encrypted channel over HTTP. A good example of this may be something like Spotify, where it's not inherently malicious, but it does some weird things that, may violate policies. And before I continue, I want to address and define a little bit about the 5 categories in the middle. They're representative of data sources that we use to correlate and make and calculate these different scores for risk and threat. So we use threat intel. So we have a number of partners in the threat intel space that we pull IOCs from. We also take into account policy violations. So just like I said, using an unauthorized application, maybe there's unexpected plain text over an encrypted, what should be an encrypted port, say like 443, and things of that nature. Anomalies. Anomalies represents our behavioral analytics. And a good example we'll get into later with the use case is a particular analytic that we call producer-consumer ratio. So one of the analytics we track for all assets in the environment is what is the ratio from which each asset produces content and sends it to another node, and what is the ratio at which it consumes content and receives it from another asset or node. And then, of course, our encrypted traffic analysis machine learning engine. So we take into account in things like RDP or TLS, a lot of different encryption technologies and services. And then, of course, the last is history. This is pretty straightforward. It's essentially a lot of our machine learning analyzers perform their action in real time. So as we're streaming network flow data, the machine learning analyzers are actively monitoring those flows and then labeling them. With the history portion, it's a retrospective lookup. So depending on the lifetime of the product living in your environment, we can capture up to 6 to 12 months of historical context in a number of different inventories. Things like passive DNS or an encryption inventory, things such as like what are the types of encryption running in your environment, or VPNs, what VPNs are running in your environment. Other things that include stuff like geolocation. So if I have a node that is communicating with a geolocation we've never talked to before, that also will be tracked as well. And what is threat? Threat is when an asset is compromised. So whenever we're able to identify any sort of infiltration or exfiltration activity, any sort of anomalies that we just talked about behaviorally, or IOCs provided by threat intel. Some examples would be a user clicking on a phishing link, or an encrypted channel that opened up between 2 nodes that we've never seen happen before. So how does this prioritize your workflow? Well, let's begin by defining the individual asset reputation. We measure it individually, but then we also allow local and global prevalence. So not only do the 5 categories that we just talked about contribute to the individual asset risk and threat scores, but you can configure different groups. So if you have different server groups, workstation groups, things of that nature, they will have their own risk and threat scores. And then of course, on a global level, we can measure that at like an enterprise level. So on to the prioritization. We'll start with risk. So how does this prioritize your work? Assets determined as high risk, depending on a number of factors, can be prioritized by your IT and network operations teams, because their job is most likely to patch vulnerable software or mitigate any risk that's been identified during a risk assessment. You can use this product to determine the risk level of each asset and group, and even your enterprise, from a network perspective. Assets determined as high threat will be leveraged by your security operations investigators. And that one's a little more straightforward. Let's talk a little bit about event correlation. So what does this mean? How do we do it? In previous talks, it was discussed a little bit about our machine learning engine and how we score different findings. But then the next stage of that is, what do we do with those findings once they're produced? One of the major problems in the industry is alert fatigue, or over an abundance of false positives, or events coming from multiple locations. Since you have, say, a diverse set of security technologies that all produce different types of alerts. This is our attempt to solve that problem. So every finding that's produced, we have a ranking system. And depending on the number of correlations that we can make, and which we'll get into a little bit, it will promote and demote the confidence level of each individual finding. So the findings will be automatically prioritized based on those things. Now, once a finding is scored and ranked, we then have another system that works above that sort of links different findings together. So if you have an initial access finding, say the phishing alert popped up, it's been validated. Well, what happened after phishing? Or did anything ever happen after phishing? Was there a persistence mechanism taking place? Was there lateral movement or exfiltration? These other activities are follow-on activities to the initial access. And that is how we do breach tracking. So our breach tracking mechanism will actually link these different findings together in a timeline and provide additional context over that timeline. So we'll begin with a first example of phishing. Say a user clicked on a phishing link and it triggered our real-time detection phishing analyzer. Great. What happens after that? Well, when the user clicks on the link, opens up a phishing site at an IP we've never talked to before, this will be part of our behavior analytics, and will trigger an anomaly. If we've never talked to this external IP before, we have analytics that we use to track node social networks. So say I'm IP 10.201.13.1, and I have an internal social network that talks to 3 other internal IPs. And then I have an external social network of all the IPs that I talk to on a normal basis on the internet. So when there's any sort of fluctuation or change in these relationships, or an addition or a reduction to these social communities, with these nodes, we'll be able to track that. So that would be one correlative point. Another correlative point would be a binary was downloaded that initiated the connection to another IP address that was different from the phishing site. And now this would be in another addition to that social community that within your nodes. Okay, so moving on with this use case. What does the persistence finding looks like? Well, once the malicious binary was downloaded and executed to the C2, we started seeing unknown VPN usage detected from internal IP to that external C2. Again, it's a VPN we've never seen before. It's an IP relationship we've never seen before. And oftentimes, threat actors, which is a strong indicator, will use commercial VPN services to route brute force authentication attempts to avoid detection. So I'm sure you're used to logging into a system, and if you forget your password 3 times, your account is locked out. Well, sometimes a VPN can sort of circumnavigate around those types of blocks. And furthermore, our anytime detection methods, which refer to our behavioral analytics, but also our history that we talked a little bit about earlier. And we're able to determine that, first, we've never seen this VPN before. Not only that, but the IP has not been observed in the past. And the connection has not been known to establish VPN connections before. Following establishing persistence, we come across some interesting information around what could be considered lateral movement. So once this VPN's been set up, we see external activity to this host. We start seeing connections to other internal IPs. And most notably, we noticed that an RDP session was spun up, either making attempts to these different nodes or establishing a connection. And one thing to note is, in this particular case, we did not observe RDP being used before for these particular relationships. So this is also something new. And as I mentioned before, with what we call the social network analysis for your nodes, we call it click analysis, essentially. So every node has a click, just like every human has a click. You have your circle of friends, and then someone new comes along, and the click that you have, it takes a while to get used to the person, maybe welcome them, or maybe deny them, right? Very similarly, nodes or endpoints also have those relationships. There's nodes that individual assets always speak to on a regular basis, and then there's ones that they don't often speak to. So if you have a system that, say, is performing a backup, maybe that relationship only exists once a month, but that relationship does exist. It's like a distant friend, right? You have this one time a month relationship, you get to see them, whatever. Similarly, this backup process functions very similarly, is that perhaps this backup procedure is only happening once a month. And as a result, we have to track that over a long period of time to see if there's a cadence. So if you look at 6 to 12 months and we see that this backup, or what we consider a backup to exist on the same time a month, every month, same sort of data volume, et cetera, then we can deduce that, okay, this is probably an expected relationship. But if it's not, it wouldn't exist in the history. And that would be a strong indicator of something new and possibly something malicious. And last but not least, and I sort of already covered this, we observe that the victim host is not known to perform these RDP connections, which is also a strong indicator. And then finally, one of the final stages of an attack is exfiltration. So we observe a new connection to an external IP we haven't seen before. Again, an expansion to our click analysis. There's now a new node we've never seen before. We're observing a significant increase in source packets, bytes, and transactions, meaning the victim host is sending large amounts of data that can be validated across different data points. Our producer-consumer ratio, which I mentioned earlier, is showing that the host is becoming a large producer when maybe they're normally a large consumer, as most users are. Most users don't send or upload lots of data. Most users consume data. And then, of course, like I mentioned before with click analysis, we have the victim host external social network has increased significantly than normal with the 3 IPs mentioned in this use case. So how does this all come together? We went over the use case for 4 different techniques, and how do you piece them together to make sense of them? Well, we have what I mentioned earlier with breach tracking. Casebook will build a timeline of events, so it'll allow the user, the investigator, to track, maintain, and modify findings from the investigation. So it's more of an organization mechanism. The analyst can go in and validate if these findings are real, and if they are, it will further promote the findings in terms of confidence. And this will be a helpful structure for any sort of reporting that needs to take place. Now, if you look at these categories, you can see that they're treated as a state within the casebook, and you'll see that in a second here. So if you click on, say, exfiltration or persistence, you will find a box like this that pops up that shows all the findings that are associated with that particular state of the attack. So you see a number of different things, such as source packets, source bytes, transactions, PCR, and ndegree.remote. ndegree.remote is a field that we named for the click analysis or the social network analysis, and the remote being that the external social network, not the internal one. And other things that are not particularly noted here is you'll be able to find additional flow data, analytic information, as well as comments shared by other analysts that have maybe investigated or reviewed a case prior to you seeing it. Now, as you perform and confirm the investigation and confirm the validity of these findings, it will also impact the reputation for the assets involved in the actual case. And they're updated in real time. And that's the end of my presentation. Thank you for your time, and I'll pass it back over to Stacy.
Thanks, Joseph. So we did have some questions come through from the audience today that I want to make sure we address. So the first question is, what is the difference between real-time and anytime detection?
Well, okay. So real-time detection really refers to our machine learning engine. We have a multi-stage pipeline that in real time, all the network flow data that passes through the environment also passes through this pipeline. And each stage of the pipeline has a different set of analyzers split up by different data types, whether it's like DNS, HTTP, et cetera. And what they do is analyze and characterize the nature of the flow data by labeling them. And those labels add additional context to what's occurring within that flow data. And then the anytime analysis is basically a set of inventories that we maintain over long periods of time. Things like passive DNS, threat intel, IP node relationship data. And essentially what we do is we map that real-time flow data to any sort of characteristics from our different behavioral analytics to see if there's any additional context that we can add to it. And that will further rank, promote, or demote these findings hopefully adding more confidence to what the analysts look at. So the idea being this is meant to reduce the volume of false positives and make things more, prioritize the things that need addressing or actioning.
Great. Awesome. Thank you. So another one we got starts out saying, I saw MITRE labels in the casebook. Are those automatically applied to events?
Yes. So as the net flow data is streamed through our pipeline, and as we characterize the net flow, if there are a certain number of analyzers that trigger and sort of bypass through the conditions that need to be met for different techniques in the MITRE attack framework, we will label it. And then there's additional measures that are taken later down, like downstream. So as an analyst is reviewing these different findings, if something's miscategorized or uncategorized, the analyst has the ability to label appropriately, as well as when the anytime analysis takes place as part of the automation, it will further enrich that data with additional techniques if it's been uncategorized.
That's great. Thanks, Joseph. So how can we help you all today? Today you've heard how you can detect and analyze some of these threats that are in your network, and hopefully you've gained some new insights into how live action solutions can work to enable security operations teams to monitor their networks and address some of these key security challenges. For some additional insight, and you get a full picture of how live action can help deliver successful network and security operations, you can review today's session or share it with a colleague. You can also review the live action channel on Bright Talk to view any of our past webinars, including the first 2 sessions of our Detecting Advanced series that we had earlier this year. You may also decide you'd like to have a more personalized one-on-one threat eye demo session for you and your team, and we're happy to get that set up for you. Or you can download free trials and access other additional resources in our attachments tab of this webinar. So I want to thank you all for attending today's session and remind you that we do have our upcoming webinar, Unmatched Network Visibility with Live Action, this coming Friday on April 1st. So you want to make sure to pre-register and not miss out on that one. Hope you all have a great rest of your day, and we'll see you next time.